Hello student and welcome back. Today we will cover lesson 5.3 Forces in Two Dimensions part 1. We will also walk through the corresponding applications and homework questions, so let's get started. Now first, the force is defined as a push or pull exerted on an object. The symbol is F. The SI unit of a force is in Newton, N, and it's defined as 1 in Newton, which is equal to 1 kilogram meter per second squared. The measuring To measure the force or the magnitude or the size of the force, we use a spring balance. This is the spring balance. Or we can use the force sensor. Effect of force. We cannot see the force, but we can observe its effect, such as setting an object in motion, changing the velocity, stopping the object, altering the shape or size of the object. Now, the types of forces. Forces can be sorted based on the nature of their interaction. This classification is based on whether the force requires direct physical contact to act. Now, for that, the two types are field forces, or we can say non-contact force, or even force from a distance. Now, all of these terms has the same meaning and purpose, and we use this description or these terms to describe any force acts over a distance without physical contact between objects. The second type of the force is contact force. This force occurs when objects are in physical contact. So the contact here is required, the contact here it doesn't require. Now, for the non-contact forces, we have only and only three types or three examples. The gravitational force, the electric force, and the magnetic force. Any other force does not included in this list should be belong to the contact force, such as tension force, normal push, friction, traction force, drag force, etc. Now to represent the force, we can use a vector. We know that the vector holds two pieces of information such as the magnitude and the direction, where the magnitude represented by the length of the vector. The larger the length, the larger the magnitude of the force is, and the head of the arrow or the arrowhead show the force direction. So for example, here the direction of the force is to the right, since this student is pushing the box to the right. The object may be subjected to multiple forces. This is why we must represent these forces. Now, the forces can act in the same direction or in opposite direction. For example, here 1 and 2 are pushing to the right, so we represent the applied force from each one by F1 and F2. Now, or they can apply their forces against each other or in opposite directions, such as F1 or the first student pushing to the right, the second student is pushing to the left. So F1 is to the right, F3 is to the left. What if we have three forces in different directions? So for example, the first student and the second are pushing to the right. This is why I draw F1 and F2 to the right. However, F3 is pushing to the left to oppose their forces. Now, this is why I draw F3 to the left. Now, to add the forces in one dimension, first we need to replace the object of interest with the dot, and then we just follow this instruction in order to complete the drawing, such as each force must be represented by distance arrow starting on and pointing away from the dot, with relative length indicated the magnitude of each force. So, for example, we have here two forces acting on the box. Now, since we are interested in the box, so we draw a dot. This dot will represent my box. Now, the forces acting are 2 to the right. However, we cannot tell if F1 greater than F2. So let's ignore the magnitude for now. And let's assume that the force provided by the first student is less than the force provided by the second student. However, in the question, they're gonna describe and clarify which force is stronger, so we can draw the relative length in more accurate way. Now, example 2 here, the two students are pushing against each other. So we replace the box. Since I'm interested in studying the box, I will draw a dot. This dot will represent the box. The two forces are the first student to the right, so from the dot and away from it to the right. The third student or the second student here, number 3, is pushing to the left, which means I must draw the corresponding force or the vector from the dot and away to the left. Now, in this example, we have 3 forces acting, 2 of them to the right and 1 of them to the left. So the dot to represent the object, the 2 forces to the right and the third force to the left. And let me remind you here, the length are drawing in arbitrary way. We don't know what are the sizes here. So I just provide this example to practice on this way of drawing. Now, for application 1, the SI unit of the force is, we know that the SI unit of the force must be Newton. So the correct answer is in Newton. Now here, Mr. KK pulls a smooth plastic box along a wooden table. The force applied by the Mr. KK is, we can notice here from the figure that Mr. KK has a special instrument. This instrument is known as the spring balance. We know that the spring balance is used to measure the size of the force. By reading the indication, we can know what is the size of the force. And the size of the force, according to the indicator, is 4 Newton. And since Mr. KK is pulling to the right, then the correct answer must be C, because C contains the 4 Newton, which is the magnitude, to the right, which is the correct direction of the applied force. Now, which row is showing the correct classification of some of the forces? Now, we have in the 2 columns, 2 titles, the contact forces and the field forces. Now, from the field forces, I can tell which row is correct, since the field forces are only 3: gravitational, electrical, and magnetic. And we can notice here the first 3 are not correct because they doesn't show, or they don't show, one of the mentioned forces that are related to the field force. Only the last row contains the correct answers. This is why I will choose D to be the correct answer. And in addition, tension force, it's considered to be contact. This is why the whole row is correct. Which of the following shows the directions of the horizontal forces acting from the 2 persons on the box, with 1 and 2 pushing the box? Since 1 is pushing to the right and 2 pushing to the left, so the direction of the forces should be in opposite direction. Now we have C and D in opposite direction. However, in part D, this force has been drawn in curved way, and this is not accepted. All forces must be drawn as a straight line. This is why the correct answer must be C. Which of the following which of the following shows the directions of the horizontal forces acting from the 3 people on the box? with 3 and 2 pulling the box where person 1 is pushing it. We can notice here from the picture that all the forces provided by the 3 persons are directed or pointed to the right. This one is pushing to the right, and the 2 students here are pulling to the right. So the 3 forces must be directed to the right, and actually 1, it shows that correctly. So A is correct. Now this is a new section here, magnitude and direction of a force. Recall that vector holds two pieces of information, magnitude and direction. The vector length indicates the force's strength or the magnitude, so we can say that the larger the length, the greater the magnitude is, and the arrowhead shows the force's direction. Example 1, determine the magnitude and the direction. So we must find the magnitude and the direction of the force F1 and F2. Now here in this grid, we can notice that they provide us with the scale. So each grid is equal to Newton. Now the formula I would introduce here whenever we have a grid and we want to find the magnitude, just follow this formula in order to find it. We just count the number of grids, so number of grids, and we multiply it by the scale. So this is the force. So we're gonna count the number of grids that used to construct F1, for example. We can see here that the number of grids we have we have 1 and 2, 1 and 2. So 2 grids has been used to construct F1. This is why I would write F1 is equal, the number of grids is 2, the scale is 2, so it's going to be 4 Newton. And since the head of the arrow directed or pointed to the right, then this is the right. However, we know that the right is a plus, left is minus. This is why I would like to rewrite my answer with the signs. So I'm going to include the sign within my solution. Now it's up to you to write it in the way that you find it suitable. Sometimes you must write it in the plus minus notation, or you can write it in the right, left, up, down notation. And in the next slide, I will introduce also the compass direction or notation. Now this is for F1. We didn't finish yet. We must find the F2. Now the F2, the number of grids in F2. We have only one grid. So this is why I must write 1 grid multiplied by the scale, which is 2 Newton to the right. However, as I told you, we will re-express our answer with the left-right directions, plus minus directions. This is why I have added plus, since the direction is to the right. Now determine the magnitude and direction for each of the forces. Now let's start with the first force. The first force is the normal. Now we can see here that the normal is consists of 4 boxes, 1, 2, 3, 4. The length of the arrow is 4 boxes. So let me write here that the F normal is equal for the number of grids or boxes multiplied by the scale, and the scale is provided here vertically, it's 10 Newton. So the answer is 14 Newton up. This is for the F normal. Now for the F spring, this is the F spring. It consists only from 1 grid or of 1 grid. Now the F spring is equal, the number of grids is 1 multiplied by the scale, and horizontally it's equal to 10 because this force is horizontal. I will take the horizontal scale, and the answer is 10 Newton. right? Finally, let's find out the F gravity, which equal which is equal to 1, 2, 3, 4 grids. So 4, and the scale used here vertically is 10, and the answer 40 Newton down. Notice that the F normal has a magnitude of 40, but it's directed up. And for the force of gravity, we have 40 again, which is equal to the normal push. However, the direction is in opposite direction. Now let's jump into the second or the next section. We're gonna define now the net force. The net force is the amount of force that remains on the object when all the individual forces acting on it are combined. So we will learn how to combine the forces now in one dimension. Now the symbol is F net, written like this. The SI unit, again, this is just a force, and the unit is in Newton. The net force is a vector quantity, which means we need to describe the magnitude and the direction of this force. Now, the magnitude of the net force can be found by applying the addition subtraction of vectors. We will see how we can do that. And the direction of the net force in one dimension is the same as the direction of the larger sum. Here we have two forces, F1 and F2, and they want us to find the net force. Let's assume that we will be asked to find the net force. In order to find the net force first, we don't know what is the magnitude of F1 and F2. First, we need to find the magnitude of each of these forces. Again, we're gonna use the scale with the number of grids in order to find the magnitude of each force. For F1, we have 2 grids, 1, 2. We will multiply it with 3, and we will get what? 6 in Newton to the right, because the direction is to the right. However, I would like to express my answer with the plus notation, because plus stands for right. So 6 Newton to the right. Now for F2, we have only one grid, but to the left. This is why when I want to re-express the answer, I must add the minus sign for this length or for this magnitude. Now to find the F net, we just put the two numbers next to each other with the corresponding signs, such as the F net is equal plus 6, because it's given by plus, and minus a 3. This is minus a 3 next to each other. Now we use the calculator, or can do it mentally. It's super easy. Numbers or operation, plus 6 and minus a 3, it's plus 3 Newton. Now let's express it again using left and right direction. Plus stand for right. This is why I'm gonna write it as right. Now, if we want to draw this force again, remember the scale used here is a 3 Newton for each box. The answer here is 3 Newton. And since the scale is for each box or each grid, we have 3 Newton. Then one grid is enough and sufficient to represent the length of the force or the size of the force. So here we can see that I draw it and construct my vector by using only one grid, because one grid is a 3 Newton and the magnitude of my force is a 3 Newton. Now for the second one, here we have F spring and F gravity. We don't know what are the magnitudes, so let's find the magnitude for each. Now the F spring is 4 times 5, because we have 4 grids, 1, 2, 3, 4, and 5 because the scale used here is 5, so 20 Newton up. Again, up stand for plus. The upward direction is a plus, the downward direction is minus. So Let's find out what will be the magnitude of the gravity with the direction. The direction, it's obvious, it's down. However, the number of grids here, 1, 2, 3. So 3 multiplied by 5, and the answer is 15. Now, let's re-express the answer using the signs. And because it's down, I will use the minus. Now, the last step, we just put the two numbers next to each other, like this, to find the magnitude of the F net. So plus 20 minus 15, it's plus 5 Newton, and the answer is 5 Newton up. Now, if we're gonna draw the 5 Newton up, we will draw it using the same scale, and the scale is says that for each vertical force or vertical grid, we have 5 Newton, and since the magnitude of this force is 5 Newton, all I need is one grid to represent it. Now, for each force diagram, determine both the magnitude and the direction. So we need to find the magnitude and the direction for the net force, so for the F net. Now here, no need to calculate the magnitude of each force because they already provided. What I need now is just to apply the F net. Remember that right is plus, left is minus. Now the direction of this force is to the right, so I would write it as plus 10. And the direction of this force is to the left, so I would write it as minus 10. So the final answer is 0. This is the magnitude of this net force. What about the direction? Whenever the F net is 0, it will be meaningless to talk about the direction. No direction for the 0 answer. Now, for the second question, or part B, we need to apply the same thing. Again, we have the forces, the magnitude of each force with the direction. So let me find the magnitude first. Now the F net is equal plus to the right, minus to the left. Now the direction here is to the right, which means we're gonna use the plus 6. And for here, it's minus. So minus a 3, and we know 6 minus a 3 is plus a 3 Newton, or we can write it as 3 Newton right. Now, as you can see here in this part, we have the compass direction, which means the final answer should be expressed in the compass direction. For example, if the net force is pointed up, we will use instead of up, north. So instead of up, we will use north, and so on. Now here again, we need to find the magnitude and the direction of the net force. However, here we don't know what are the magnitudes for F1 and F2. So first we need to find F1 and F2. However, I'm gonna do that quickly. No need to write more steps now because the operation now is obvious. We have 4 grids, 1, 2, 3, 4. 4 multiplied by 50 is equal to 200 Newton. So F1 is 200 Newton. For F2, we have 1, 2, 3. 3 times 50 is 150 Newton. Now, right plus, left minus, and the F net, it will be given as plus 200 because the 200 is directed to the right, minus 150 because 150 is directed to the left. Now, the final answer is plus 50 Newton. However, I must re-express my answer using the compass direction. And since the forces are acting along the horizontal axis or horizontal forces, then we will use the horizontal direction, and the horizontal direction has two directions, the east and west. Since the answer is a plus, then we will write it as 50 Newton, E, and E stand for east. Now the same thing can be done here. However, here we have two different directions along the vertical. So F1 is up, F2 is down. However, the final answer must be expressed in the compass direction or using the compass direction. Now pay attention here that the scale used is 25 Newton, which means each grid is equal to 25 Newton. We have 1, 2, 3 grids. 3 times 25 is 75 Newton. And 1, 2, 3, 4 grids times 25 is equal to 100 Newton. Now up is a plus, down is minus. F net is equal plus 75 minus 100, and the answer is minus 25 Newton. This is the F net, but since we have this symbol, it means the final answer should be expressed in compass direction. So it will be 25 Newton, and the direction is to the minus, to the south. So S. This is the final answer. Now here we can immediately combine these two forces together because they are pointed in the same direction. So 75 and 100, this is 170 Newton. And for this one, this is to the left, this is to the right. So I would write F net as 175, the two forces together to the right. This is why we have plus, and one force to the left. So we may add the minus to it. And the final answer will be 25 Newton, or you can say 25 Newton, right? Now here also we have two forces are pointed to the same direction, in the same direction, so we can combine them together. 0.6 and 0.4 is just 1.4 Newton. And this force is directed to the opposite direction, or in the opposite direction. Up is positive, down is negative, which means the F net is equal 1.4 minus 1 equal to 0.4 Newton. Since it's a plus, which means it's directed to the positive, positive is up. This is why I would write it as 0.4 Newton up. This would be the value of F net. Now the balanced and unbalanced forces. If the net force is zero, and this is what we saw in the first application, we found that the F net is zero, then the forces acting on the object are balanced forces. Now we have two types of balanced forces here in this situation. The forces can be balanced along the x-axis or the horizontally, and they can be balanced along the y-axis. So if we add the forces along one of these axes and we found that the F net there is zero, then we can say that we have balanced forces along the given axis. What if we didn't find F net is equal to zero? Then won't be balanced forces case. This is unbalanced forces. So for example here, if we recalculate the two forces F1 and F2, we will find that F1 is equal 1, 2 times the 360 Newton. And for F2, we have 3 Newton because it consists of one grid times the 3 is a 3. Now, if we add them together, we will get 6 plus 6 minus a 3, and the answer is plus a 3 Newton. Now, this is what represent is the F net. Now the F net, as we can see here, is not equal to zero, which means the forces are unbalanced. However, we can solve the same question in different way, or much smarter way. Now we just look at the left and right. If they're gonna be equal, the left hand force and the right hand force. If they are equal, then the F net will be zero because at the end you're gonna subtract the same number from itself twice. So for example, let's say the F2 is larger like this. This is F2. Then the left will be equal to the right. If this is 6, this is gonna be 6. And if we subtract them from each other, we will get 0 because 6 minus 6 is 0. However, here they are not equal. So if they're gonna be equal, left equal to the right, then the F net is equal to 0. If left does not equal to the right, then F net cannot be equal to 0. So we can say that F net equal to 0 if left equal to right. So the forces on the left are equal to the forces on the right. This would be the x-axis balance forces or the horizontal forces balance forces, or they are balanced along the horizontal. Or we can say the up equal to down. So the forces upward are equal to the forces downward, which means again the F net is equal to 0. Now, what if F net does not equal to 0? Then from the first moment we can notice that left must be not equal to right. So they're gonna be unbalanced horizontally or along x-axis, and up does not equal to down, and they're gonna be unbalanced vertically or along y-axis. So here, let's get back to this case in example 3. We can notice that left does not equal to the right. Here the force is equal to 3. Sorry, here the force is equal to 6, and here the force is equal to 3. Since they are not equal, the F net cannot be 0. So as a result, this is unbalanced forces because left does not equal to right. Another example, let's evaluate if the up equal down here. Here, 3 grids multiplied by 5, it's 15 Newton. Here, 1, 2, 3, 4 grids multiplied by 5, 20 Newton. Again, up does not equal to down, which means they are unbalanced forces. For example, 5, here, as we can see, the magnitude on the right is equal to the magnitude on the left, which means we have balanced forces. If you want to double check, you can say that F net is equal 10 minus 10 because this is plus, this is minus, and the answer is 0. So no need to go through the calculation now. We can say, or you can get the result just by evaluating the left and right forces or up and down forces. So here in this case, we have balanced forces, and these forces are balanced horizontally. Now, in this exercise or application, we need to evaluate whether we have balanced forces or not. Now, as we can see here, on the right-hand side, the force that is pointed to the right is 6. The point that is pointed to the left is 3. They are not equal, so they cannot be balanced. So left does not equal to right. L stands for left, R stands for right. So left does not equal to right, and the case is unbalanced forces. Now for this one, before I start evaluating them, I need to combine this and that. So in total, 2 and 3, it's 5 Newton. So on the right-hand side, the total forces are 5. And on the left-hand side, we have only 3. And we know that 5 greater than 3, which means, again, left does not equal to right. And we have unbalanced forces. Now, the following force diagram shows four forces acting on an object. The net force is, now here we have four forces acting on the object. As we can see here, 20 on the left and 20 on the right. So they are balanced horizontally, which means the F net horizontally is equal to 0. And here we have 10 and 10, which means up equal down. And the case is F net equals 0 vertically, which means the final answer 0 horizontally, 0 vertically, and the correct answer must be A. Now, for the homework section, let's start solving question 1. Given that each of the objects is subjected to balance forces. Now, here they provide me with very, very important information about the state of the forces. They are balanced. What does it mean by balance? Immediately, I should recall that the balance forces means the F net must be equal to 0. And I can say up equal down, left equal right. So they must be equal because I know that they are balanced. We need to find for each of the following cases the value of P. We don't know what is the identity of P that makes each system has balanced forces. Now let's start with A. In A, we know that the forces must be balanced. However, I don't know what is the value of P here to make the assumption true. Now, in order to make the assumption true, the forces are balanced. P must be equal to 10 or up equal to down. Now, let me construct the equation. Up equal down. Up, we have P. Down, we have 10. So, P must be equal to 10 in order to verify the condition here. Now, for part B, again, we can notice here that they are balanced vertically, 10 up, 10 down, and they must be balanced horizontally. Horizontally, we must have left equal right. Now, on the left, we have a 30, sorry. On the right, we have P. Swap between left and right, and you will get that P is equal 30 Newton. Now we know what is the identity of P. Here again, we need to know the identity of P to make the condition here valid in question C. We can notice that they are balanced vertically, 10 up, 10 down. Now, what will be the value of B to make the system or the forces balanced horizontally? Now, we're going to write the condition along the horizontal, which means I will write left equal right. On the left, we have 50. On the right, we have two forces, and we must combine them together, P and 2P. Here on this stage, we are evaluating the magnitude of the forces. The magnitude on the left is equal to the magnitude on the right. So this is why I didn't add the minus. If you wonder about why I didn't add the minus, because here I'm evaluating the magnitudes of the forces. Now, from the math session, we know that P and 2P is just 3P. Now, let's complete the work in order to complete the isolation for P. Now, the operation between 3 and P is multiplication. And whenever I want to move the multiplication to the other hand side, it becomes what? Division. Or you can say that in order to complete the isolation, I must divide over 3. To cancel the 3, I must divide it over it. Now, here, 3 with 3 cancelled out, and 50 over 3 is the value of P, and it's gonna has this value, 16.6 Newton. So the P is 16.6 Newton, this P, And for this 2p, it's gonna be 2 times 16.6, which approximately equal to 16.6 multiplied by 2 is equal 33.2. If you add to it 16.6, you will get what? Approximately 49.8. But remember, I just took one decimal after the decimal point, one number after the decimal point. If I'm gonna include all the numbers that are coming after the decimal, I will get something equal to the 50, which means equal to the left. Now let's complete the solution now. Now the force F required to balance the forces is, so here they want me to make the whole system under balance forces. What is missing here? Another force to complete the balance vertically. They are balanced horizontally, but they are not balanced vertically. So I need another force with the same amount acting downward. So the correct answer is B. Now, given that each of the object is subjected to balance forces, find the value of P. So again, here we need to find the value of P. The condition is we have balance forces, which means F net is equal to 0, and we can say left equal right, up equal down in magnitude. So no need to worry about the signs here. Now, horizontally, to make them balance horizontally, left must be equal to right. So what will be the value of P to make this system balance horizontally? Now, on the left-hand side, we have 12. On the right-hand side, we have 2P and P. Now, 2P and P is 3P. Now, let's swap between left and right, and we can get 3P is equal to 12. Let's divide over 3 to complete the isolation. 12 over 3 is just 4 Newton. So we must have here 4 Newton for the P, and for the 2 of P, so 2 times 4, it's 8. 8 and 4 is 12, so left equal right. Done. Now, in this question, again, we have balance forces, but this time we need to find the value of P and Q. So as we can notice here, we have two horizontal forces, two vertical forces. Let's start by evaluating the horizontal forces. Now, and let's ask a question here. What will be the value of P in order to make the forces balance horizontally? Horizontally means left equal right. On the left, we have 25. On the right, we have the 5P. Now we can swap between them without changing anything. Now, finally, we just divide over 5 to complete the isolation. And we know that 25 over 5 is just 5. So if the P is equal 5, then the system will be balanced horizontally. Now, P is 5, but don't forget that we're going to multiply it with 5 because we have 5 multiplied by P, and the identity of P is 5. This is why I got 25, which is equal to the left. Done. Now, what about up and down? Let's make them balanced by knowing or figuring out what will be the value of Q. Up equal down makes the system balanced vertically. Up we have Q plus 10. Down we have 20. Now let's move this to other hand side by changing the sign. Q is equal 20 minus 10, and the Q is equal 10 Newton. Now remember, the Q is 10, and we need to add to it 10, and we'll get to 20, which is equal to down, and they are balanced vertically. Now, in this question, we have four forces are exerted on an object as shown in the figure. Which of the following best represents the net force exerted on the object? We need to know what will be the net force with the direction. In order to figure out the answer, we need to combine all the forces to get the F net. Now, no need to calculate F4 and F5 because they are already balanced. So, vertically or along y-axis or the vertical axis, the F net is 0. So let's forget about it because up equal down. What will define the F net is what? The horizontal forces. So let's focus more on the horizontal forces by finding the value of each of these forces. So what is the value of F1? We have 3 grids, 1, 2, 3 for the F1. This is the length of the arrow. However, the number of grids is not enough. We need to multiply it with the scale, and the scale provided here is 4 Newton. So 3 times 4 is 12 Newton. Now 2 times 4 is 8 Newton. And for F3, we have 1, 2, 3 times 4 is 12 Newton. Now, for the F net, we can just write 12 to the right and 8 to the right. So 12 plus 8. And since the only force acting on the left-hand side is this force, so we will write it as minus 12. Now 12 with the minus 12, it cancelled out, and what left is 8. But since we are talking about horizontal force, we know that the right will be plus. And since here we have a plus, then the direction is right. So F net is 8 Newton, right. This is why the correct answer is what? C.